Okay, general math students, in this video we're going to continue this example. In the previous video we did a residual analysis and decided that based on the residual plot this model is appropriate for this data. We're going to continue now into some questions in which we examine the residual plot and answer some questions about the points in the scatter plot and the residual plot. So it's important to understand the difference between what the data means in a scatter plot as opposed to a residual plot, what these coordinate points actually mean. So that's what we're going to discuss. So first off, we're told here that the point 2 and 12.3 is on the original data plot, and we're asked to interpret it in words. So that's this point over here, 2 and 12.3. Okay, now this might seem complex, but it's really relatively simple. These coordinate points always start with the x variable and then the y variable. And we can see if we look at the x-axis of this graph, that is the weight in tonnes, and the y-axis of this graph is the fuel in litres per 100 kilometres. So all this is saying is that a truck which carried a weight of 2 tonnes used 12.3 litres of fuel per 100 kilometres. So we're just interpreting the variables from the residual plot and using the numbers that are given in the coordinate point to do that. So a truck which had a weight or a load, I suppose they're carrying different loads, so this is the amount that it's carrying. So you could say a truck which was carrying 2 tonnes. You can use your own words to some extent on this. Used 12.3 litres per 100 kilometres. Okay? All right, now in the next question we're asked, what fuel consumption would the equation predict for a load of this size? Righto, so the equation is there. If we ran the residual analysis on this data, that would be our equation of our linear regression. I beg your pardon, if we ran a regression analysis, not a residual analysis. So if we did a linear regression, that is the equation that we'd obtain. So we're going to use that to make some predictions. So it's all about how do the predictions match up with what's being, or what actually happened. So predictions from the line of best fit versus what the data, the actual data that was collected. So we're going to substitute that value, W equals 2 tonnes, into this equation. So the fuel consumption would be equal to 1.6 by 2 plus 8.4. Okay, I better work that out. 1.6 times 2 plus 8.4. Oops, just fix that up. And that is 11.6 litres per 100 kilometres. So it's just interesting here to note that the equation is predicting that that's how much fuel would be used, but what actually happened was that the truck that carried that much weight used 12.3 litres, so a bit more than what would be predicted. And this often happens, that the data doesn't match up with the prediction. So what happens in real life often doesn't match what the equation would predict. And that's okay, the equation is just making a prediction about what will happen. And that's why we've got to be so careful with the predictions we make. We've got to make sure that the model is appropriate and also take into account whether we're doing an interpolation or an extrapolation for that prediction. So the residual value. Now residuals, we talked about how that's the gap between the line of best fit and the actual data point. So that's all we're calculating. We do the actual value which was 12.3, and we subtract the predicted value, which was 11.6. So our residual value is 0.7 litres per 100 kilometres. And that is shown on the graph there. There is that point there, and there is the residual, the gap between the line of best fit and the actual data point itself. Now we're asked to interpret this in words. What does a residual point mean? Well, I've already really elaborated on it if you think about it. I was talking about how the actual fuel usage was 12.3 litres per 100 kilometres, and the equation was predicting less than that. And that's basically what this is that the equation is predicting 0.7 litres of fuel less than what actually happened. Okay, now I'm going to describe it very slightly differently and talk about how more was used. So in real life, more was used than what was predicted. So beg your pardon, I better start with this 2 here. That's still important. So we'll mention that a truck which had a weight of 2 tonnes used 0.7 litres per 100 kilometres more than predicted by the equation. Okay, now if we looked at one of the other residual points, say this one here, what we can see there is that there's less fuel being used than what's predicted. So it can be more or it could be less. This point here that I've just highlighted, that looks like it's bang on. The equation agreed with what happened in real life, or vice versa. Okay, so that's how we interpret those residual plots. Those questions do come up from time to time. So make sure that you go ahead and access the description for this video and try some of those questions that are in that description for the video.